Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 United flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So right now I'm in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing you the cockpit instruments, the displays and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb descent of the aircraft in 10 times in thousands feet per minute. As the steepness of the trigonometric angles decrease, can climb descent. We have also the artificial horizon with the altitude indicator and the pixelarity decrease and the bank angle increase. The ILS localizer, we use the ILS localizer that receives from the onboard antennas of the aircraft the radio frequency transmitted from the threshold antennas of the runways runways we use for takeoff and for landing. So we have the Zurich International Airport Lszh in Switzerland and runway 14. I'm going to use this specific ILS localizer frequency and a magnetic north pole heading of 136 degrees for localizer, horizontal localizer alignment, and also vertical angle of approach with glide slope. So we're going to have the ILS localizer, the instrument landing system of the airport. You're gonna see how we're gonna use it in the primary flight display and the autopilot flight director system panel over here, the navigation display also. So you're gonna see the navigation instruments of the aircraft, and so we have in the primary flight display also the ILS localizer crossbus, the flight director crossbus for automatic for manual guidance of the aircraft, and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and unseater with the autopilot and the auto throttle, later vertical navigation modes. We have also the HSI, the horizontal situation indicator that displays the magnetic heading and track, and also the degraded display of the aircraft that contains the flight plan we're gonna create later using the flight management computer. So I'm gonna show you how to create a flight plan or a flight path or a route for this aircraft and this flight, every flight separate. So I'm gonna use the navigation display also. I'm gonna show you the horizontal and vertical profile of the navigation navigation display as the aircraft flies. We have the magnetic north pole and geographic north pole and magnetic variation depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the red, green and yellow reflections from the weather radar that also display the terrain elevation around you, so you can see the terrain with red, amber, yellow or green, and also you can see here some terrain parts, some mountains over here. You can see the Switzerland, Germany and France over here. So you can see also the aircraft as we're gonna be flying over here, how far above the ground we're gonna be flying. Also you can see the airports displayed with the blue 4-letter name. So you can see the terrain, you can see also the sea, lakes and rivers with blue. You can see also the airports where they are located. So we have our own airport, the runways we can use for takeoff and for landing, the runway length, the direction of the runway, and also other airports. Also we can use the taxiways, you can see them from the GPS. So we have also the GPS, the inertial reference position of the aircraft. We have also so the GPS coordinates, the longitude and the latitude from the flight management computer. I'm gonna show you how we can align the aircraft. We have also the navigation aids, the workstations, ADFs and NDBs. You can see them displayed in the navigation display. We have also the waypoints which are horizontal, vertical navigation fixes and altitude and airspeed constraint. The aircraft is gonna have to fly through some waypoints. We're gonna select from the flight management computer when we're going to create our flight plan. It's gonna give us a route legs with one waypoint by another from takeoff, from the runway we're gonna use for takeoff all the way back. We're gonna use the same runway. So you're gonna see the purple line, the line that connects the flight plan. So you're gonna see also In the navigation display, we can see other aircraft that fly around our own aircraft. You can see the distance where they are located, the altitude difference from our aircraft. We have the transponder, the ADSP and ADC transmitter receiver to transmit our frequency to other aircraft in the air traffic control, and also receives from the other aircraft, and with his computer he can calculate the other aircraft position and distance from our aircraft, also the altitude difference from our aircraft, how many feet, hundreds and thousands of feet higher or below from our aircraft when we're flying, for instance. Also you can calculate whether they climb or descend with respect to our aircraft. Also, we can calculate the velocity closing in between our aircraft and the other aircraft. Will give us a warning from the TCAS system, the Traffic Collision Advisory System, so we can make an avoidance maneuver in the air, and also we can monitor the traffic in the ground, in the taxiways and the runways. You can see the other aircraft with a diamond shape, and also we can see we have the autopilot flight director system panel. I'm gonna start showing you one by one all the functions of the aircraft, the systems. So you can see here we have also, hope you can see a better view over here. Of the screen, so you can see I'm gonna use the flight controls to control the aircraft flight path in the air. So you can climb, descend, make turns to the left and the right. So I have this side stick, it's identical to the Airbus side stick. You can see it controls the control column and the control wheel of the aircraft. So we can climb, descend. We have the side stick back and forth, and also the ailerons and spoilers, control wheel, side stick left and right. Also the rudder pedals over here to make yawing turns. Also to control the vertical stabilizer, the vertical tail of the aircraft, and also the nose wheel steering. We have the tiller here. This is interconnected with the rudder pedals. So I will talk to you about the flight controls in a couple of minutes. So we can start here with the screens. You can see we have the primary flight display over here. You can see the airspeed tape over here, the airspeed indicated, the airspeed selected from the autopilot flight director system panel. That's going to be our flight speed when we take off, after takeoff actually. So we have also the vertical, we have the altitude tape, the barometric altitude above this level, and the target altitude selected from the autopilot flight director system panel, the vertical speed indicator here. You can see how many hundreds and thousands of feet we climb. This this needle moves up, and when we descend, this needle moves down. So we have the barometric altitude setting over here, 29.92 inches of mercury for the outside atmosphere. Barometric pressure, so you can see here we have set it using this the FS panel. You can see the baro set over here in inches of mercury, so we have 29.92 inches of mercury right now, or 1013 hectopascals. Over here we have the minimum radio. Over here also selected 200 feet as it displays with a green color. We have also here for the display, the navigation display, you can set the plan, map, or menu. Also the range over here, distance, weather radar, traffic and terrain on the display. We can also set the meters, flight path vector, accept, cancel and reject some warnings over here. We have also the system CDU info, checklist, communication, navigation display, left or right, ACAS. So right now we have the engines indication here in the open display, in the extended display. We use two displays in the left side and one display, only the navigation display on the right side. So you will see later the systems of the aircraft that are containing the overhead panel mainly. Also the flight controls, you will see them in where is the engines indicator right now. So I'll talk to you right now about that. So you can see here we have also in the we have the artificial horizon over here, the blue and the other color. We have the pitch ladder in degrees over here. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pits up or pits down. So we have also the bank angle in degrees over here. So we have also the bank angle degrees, the flight director. You will see the ILS localizer, same like you will see the needle here in the vertical, the glide slope. We have the takeoff ground right now from the system of the aircraft, from the auto throttle and the autopilot direction system button. So if we've moved the thrust levers forward, it will arm. So we have also the HSI ADF left and right over here, as you can see, GPS display and the heading. So you can see the airspeed here. Over here we have the airspeed selected, 200 knots, the altitude 10,000 feet, and the heading 360 degrees is the same values selected from the autopilot flight director system panel over here. So we have the airspeed guidance of the aircraft in nautical miles per hour. Right now it's 200, 360 degrees heading, and the altitude here 10,000 feet. So you can see over here 10,000 feet altitude as it displays. So we have the same here in the primary flight display, both of them, both sides. So you can see here 200 knots, 10,000 feet. You will see later different values, and also the heading is 360 degrees over here, or zero heading. So you can see also in the vertical display here we have also 10,000 feet selected. Right now this magenta purple line, we're gonna be flying higher, so you will see when we're gonna be leveling off in climbs or in descents. So for the autopilot flight director system panel over here, you can see we have the autopilot engage and disengage switch over here, as you can see. So you can see autopilot engage, disengage, the LNAV, the WinNav, lateral navigation, vertical navigation, flight level change, climb continuous, auto throttle, flight director on and off, engage, disengage, auto throttle, left and right arm and disarm, bank angle, automatic and heading, select hold. You can also press the switch here for the altitude, the airspeed, maybe the heading, select over here, as you can see. And also the altitude here 10,000 feet, the world localizer, and the approach for Rotterdam. So you can see the other side also displays pretty much the same information. You can see the airports over here. So we have the navigation display over here, as you can see. We have the horizontal and vertical profile, as you can see, the terrain map, the airports where they are located around airport, the magnetic north pole here, 333 degrees. The range 18 nautical miles, so the range we set over here from these streets. You see range. So this sets the range, also the map of the terrain, and also the vertical display. You can see the aircraft when we're gonna be flying. Also the engines indication from the FAREX, the Fuel Authority Digital Electronic Control Computers. So we have the FAREX, the Fuel Authority Digital Electronic Control Computers, one installed per engine gearbox, dual channel redundancy, one channel phase, the other takes over controls, multiple displays all the engine data, using the upper and the lower ACAS, engine indication control system display, or multifunction display. So we have the N1, which is a low speed starter, sub low pressure compressor, and turbo of the turbo fan, which is engine. The exhaust gas temperature per engine, the N2, which is a high speed starter, sub high pressure compressor, and turbo of the turbo fan with the engine, the fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, temperature, quantity, and the vibration of the N2 stage of the engine. So you can see also over here the data from the FAREX. The FAREX apply the thrust when you apply thrust from the side stick here, the thrust levers over here. So you apply the thrust, it will select the commanded thrust rating. It will give command the engines, the fuel flow, and other settings. So we have the N1, which is low speed starters, low pressure compression tube, and of the turbofan engine, the left and right, 22 right now, and it's decreasing is idle, 99.2 is takeoff over here at the O. FNC messages, exhaust gas temperature, engine left and right, fuel flow, the N2, which is the high speed starters, have high pressure compressor tube of the turbofan engine. Fuel flow prints per 1000 kilograms, thousands of pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. We have also other settings and displays. You can see, for instance, over here we have the outflow valves of the cabin pressurization system. When we fly, we climb and pressurize the cabin of the aircraft. You can see the outflow valves move open or close for pressurizing or depressurizing. Cabin altitude, so when we climb to like 45,000 feet over here, the differential pressure is gonna be 7.8 or 8 psi, and the cabin altitude should be 6, 7 or 8,000 feet. The rate also will can descend. You can see now manual with amber landing altitude. So we have also the stabilizer trim, horizontal stabilizer and rudder trim, the flaps position, the gross weight over here for takeoff, with the total fuel on board, saturated air temperature. So we have in thousands of pounds idle and fuel temperature -6 degrees. So takeoff weight is 358 with 35,000 pounds of fuel, so it's 5.8. So we can see other systems and data. Before I'm gonna show you the flight controls of the aircraft over here in more detail. So I'll show you the autopilot flight direction system panel. So I have to show you we have the horizontal stabilizer trim over here. You can trim the horizontal tail of the aircraft as we fly. So we use this switch to trim the elevator of the aircraft up, and this way to trim the elevator down. So this gives an aerodynamic effect in the aircraft. You trim the elevator up, you pitch the nose up as you fly, and you trim the elevator down, you pitch the nose down. So you can see here elevator trim over here. Left click down and right click up over here. So this is how you can trim the elevator of the aircraft for flying. Elevator trim, left click down and right click up. So this is the normal channel of the flight control computers over here. So it's very important if I to use the manual trim to balance the aircraft. So this way you trim the elevator up and down and balance the nose, pitch up and nose down, as you can see. So you have also the flaps limit over here. You can see the horizontal stabilizer, as I told you. Trim position over here, 4.5 right now is automatically perhaps. You can move manually. Also when flying after takeoff and after, until landing, takeoff, climb, cruises, and approach and landing. So you can see also the control wheel. You can see I use this switch for the horizontal trim stabilizer over here. Elevator, some aircraft have the whole stabilizer, like being the Airbus. So we have also the head-up, the autopilot disconnect over here, switch, disengage, and the head-up display declutter over here. So we have 1, 2, 3 switches over here. Also we have the alternate pitch trim. You can see pitch trim alternate. So we have the pedestal. You can see the radio management panel here. I will talk to you now. The engines controlled here, the fuel flow, left and right engine. We have also the stabilizer alternate pitch trim. So this way you pitch trim the elevator in the alternate flight control channel. Again, this way you pitch the nose up, and this way you pitch the nose down, trimming either way, either left and right. So you use together. So you can see again, elevator trim again. also it's doing the same thing like in the control wheel. You can set, we have also the parking brakes over here. As you can see, we have also the stabilizer trim over here, cut-off switch, the left and the right, as you can see. So as I told you, this is a fly-by-wire aircraft, so this is for cutting off the auto trim function from the autopilot flight director system panel. This is a fly-by-wire aircraft like the Airbus or other Boeing models. You have the automatic trim of the aircraft as you fly. The aircraft can balance itself in flight automatically, so you will see how we're gonna do that. Also, when using the auto throttle, the thrust levers, we have also, I would say, the flight control computers over here. We have the primary flight control computers in the auto position over here. Primary flight control computers in the auto. And when we have some failure in the hydraulic system, you can see the primary and demand left and right engine and electric. Over here pumps and the backup, the ram air turbine. So we're gonna have some failure that affects either the left or the right elevator or stabilizer trim. So this is for all Boeing 737, 747, 757, 767, Boeing 777 and Boeing 787. You come down here, you open from normal to cut off like this. The stabilizer trim, and you use only you can see stabilizer left and right, cut off switch from normal. So you use the alternate pitch trim over here after that for pitching up the elevator or pitching down, and you can use all the time the manual trim over here, manual trim switch, as you can see. So this is to relieve the air pressure from the flight controls when you're flying. Also, you can see the outside view of the horizontal tail. So we can climb the descent using the side stick in the Airbus aircraft or the elevator movement. We have also the control column, the yoke of the Boeing 787 or other Boeing aircraft. So in the Airbus you move the side stick up and down. In the Boeing you move the yoke, you move the elevator. So this is the pitch axis. I will talk to you. You can see from left, from wingtip to wingtip, we have the pitch axis of the aircraft. You can pitch through the center of gravity. So this is the pitch axis here. You move the elevator up and down in the Boeing 787 or other Boeing aircraft. In the Airbus you move the side stick just back and forth. So we have also I will talk to you about Newton's physics, aeronautical and aerospace engineering, and derive you some principles that we need to know for flying the aircraft. So also the outside view, I will talk to you about the aerodynamics of the aircraft, burning fluids and other stuff we need for the air transport pilot license and the commercial pilot license. So you can see here, so you can see the outside view of the aircraft. You see the wings hold the weight of the aircraft, the forward wings when we fly mainly. You can see also we have the mean aerodynamic chord position, the Mach, which is where the maximum aerodynamic lift occurs in flight, is where also the center of pressure is moving forward and aft in the top surface of the wings. Also where the stall will begin the flow of the air from the top surface becomes detached, and we have the aircraft stalling the wings so for a given angle of attack. So we need to monitor here in the primary flight display when flying. You will see later we're gonna be flying having the airspeed indicator here. We're gonna be having the amber and red color indication down here of the stall speed. So we need to apply thrust and push the yoke down to avoid the stall of the wings. So you can see here we have also the thrust vectors from the engines that move the aircraft forward. Over here the Z plus from the exhaust cones of the jet engines, as you can see. Also the bypass, we have the high pressure turbine and compressor, and low pressure compressor and turbine, and the front fans section over here. We can see also we have where is the aerodynamic cord. We have the left and the right wing fuel tank, and also the center tank fuel. And this is where is the center of gravity of the aircraft transverses through the aerodynamic cord position over here. So this is the yawing axis of the aircraft. We can apply the rudder. So the yawing axis is the vertical axis. We use the rudder for making left and right, left here and right turns, as you can see, the rudder pedals. And also we can control the nose wheel of the aircraft 76 degrees with the rudder pedals in the ground, or with the tiller from 0 nodes. So you can see the tiller and the rudder pedals. We have for the vertical stabilizer is interconnected for the rudder control, and also the rudder the nose wheel steering. So we move the nose wheel 76 degrees from 0 to 45 knots in takeoff, nautical miles in takeoff. Then it decreases from 76 degrees to 7.6, all the way up to 80 knots. It disconnects, so we have zero deflection from the front wheel above 70 or 80 knots. And we have only the rudder aerodynamically effective, so the rudder is also aerodynamically effective from 45 knots and over airspeed in takeoff or in landing, which gives a decrease in the deflection of the nose wheel. So this is the yawing axis over here through the center of gravity. You control with the nose wheel and the rudder, as you can see. This is the rudder also versus the nose wheel of the aircraft over here, the front nose wheel. So we use, as I tell you, you can see the rudder pedals, left and right. Also we have the toe brakes and the rudder pedals. So I use the side stick like this, left and right, to control the rudder pedals. So this is the yawing axis. We have the pitch axis from wingtip to wingtip. You can see wingtip to wingtip, it's the pitch axis. You use the elevator for climb over here and for descent. Also the elevator trim, the trim stabilizer, if you don't want to use somewhat side stick or yoke deflection. So we have the side stick deflection in the Airbus and the yoke in the Boeing for climb and descent. Also we have this axis, the longitudinal axis from nose to tail. Transverse as the other axis is the longitudinal axis. We can make in the Airbus the left and right side stick turns. Use the ailerons and the spoilers, inner ailerons and outer ailerons, and also spoilers. So we have in the Boeing the flaperons, ailerons and spoilers instead. So you can see if we use zero deflection, you can see we use ailerons and spoilers, left and right turns, and flaperons. So this is the control wheel over here in the Boeing aircraft, left and right, and side stick left and right in the Airbus. No different, same function. Also the elevator, same function, moving up and down for climb descent. So you control all the flight controls are the same. So you can see the outside view, side stick deflection, elevator, rudder pedals. So we have also the speed brakes extended like this. So we have also from aerodynamics, you can see the bottom surface of the wings is more flat. We have also the flaps extended. So when we take off, we accelerate to like 140 nautical miles per hour, like 250 kilometers an hour. With the airflow is moving slower. Also we have a positive angle of attack, so the airflow is moving slower below the wings, so we have higher air pressure, which pressurizes the aircraft wings and weight up into the air. So you can see also the top surface of the wings over here. we have higher curvature, so the airflow is moving much faster above the wings. So this creates a lower air pressure, which sucks the wings and the weight of the aircraft up into the air. So this is the basic aerodynamics we need to know for the air transport pilot license, also for the flight controls of the aircraft and the commercial pilot license. The aerodynamics we need to have knowledge of how to apply the thrust, also the flight controls in flight. So as you can see, I'm gonna show you also the other systems of flight management computer in a couple of minutes. Also another view over here. So I'm gonna show you one more nice view of the flight controls of the Boeing 787. You're gonna see how I'm controlling. You can see the side stick deflection is proportional to the yoke deflection. Also, as you can see, both the captain and the first officer are moving together, or they're interconnected in flight. Unless you have a failure, you have an override mechanism for either side. So in the Airbus you have the side stick priority anyway in the left and the right side. So flight controls interconnected. Also I'm gonna show you over here. So you can see also we have the flaps position over here. We position the flaps over here, extend and retract. So it's necessary if you need to have more lift, use lower airspeed. Also the speed brakes over here, I'm gonna show you later. The switch, the fuel control, left and right tensing, the thrust levers, the auto throttle, disengage switch, this switch over here, throttle control, disengage, takeoff, ground, and thrust reverse. So you have the fuel control over here, and the fire extinguishers for the left and right engine, plug and switch, transporter, rudder trim over here. So I'm gonna show you, you can see also we have the landing gear over here extended, down the flaps position, the alternate gear over here, auto brakes here, rejected takeoff or arm and disarm. You will see, it will display here if you arm them. Auto brakes, parking brakes now set. So I'm gonna talk to you also about the other systems. So we have a couple more minutes to show you all the flight controls. So you'll see this view of the aircraft using the flight controls, a better view. And I will talk to you about the flight management computer right after that. So I hope you have a better view now of the flight stick that I'm gonna use to show you the flight controls. So you can see here the flight controls of the Boeing 787. This nicer view. So you can climb the descent, make turns left and right. You can see also another aircraft is coming for landing. So we spotted a nice aircraft over here, Boeing 737. It's coming for the runway 16, the one beside us. Gonna use this runway instead. So you can see again using the flight controls of the aircraft. You can see the side stick that I'm using here. So I hope you like my side stick, the deflection. So we use for climb and for descent, for making turns to the right, to the left. The thrust levers also, thrust control over here. You can use all the thrust levers, moving forward or aft. So this is the thrust control over here. You can set the thrust commanded by the engines, by the Farex control. Also hope you like my Airbus side stick. Make turns right, left, climb, descent, horizontal trim stabilizer. So we have again all flight controls, the same like in the Boeing aircraft. So you can see side stick, deflection up and down, thrust levers. So we see also the outside view again using this flight controls movement. There are other pedals, the elevator, climb and descend, make left and right, also turns. So we're going back over here. So this is so much for the flight controls lesson. We had to do that. Now I'm gonna show you the rest of the systems of the aircraft. So I'm gonna show you the flight management computer over here. You can see I'm having my own computer and my mouse pad over here, so I can control all the functions inside the aircraft that I need. So this is how the setup. So you can see I can use my mouse pad for controlling over here. For controlling this mouse pad for the flight management computer, I'm gonna set the flight plan right now. So you can see we have the indications here. We have the identity. You can see the purple inside the box over here as moving position, performance over here, and takeoff, approach, and I see it's navigation, flight plan, other functions, the alphanumeric keyboard over here, the commands. So we're gonna be having also interconnected with the autopilot flight director system panel this flight plan. You can also set the displays here. You can see FIR airspace data, waypoints. So I'm gonna show you also that. So we're gonna input all the data of this aircraft for this flight, and includes the empty weight class, the passenger class, the cargo class, the fuel on board, where the fuel is on the left and the right wing. We have 30% in the left and the right wing and 10% in the center tank. So the flight management computer is gonna calculate the takeoff gross weight and the mean aerodynamic chord position using the center of gravity of the aircraft. The mean aerodynamic chord where the maximum aerodynamic lift occurs, also where the stall begins. Also this gives us the horizontal trim stabilizer for takeoff, also using the stabilizer, the flaps position. I'm gonna use 15 degrees of flaps. Also we fly with burn fuel. The center of gravity is recalculated every second because it's shifted as we burn fuel in flight from takeoff, climb, cruise, descent, approach, and landing. Also the stabilizer trim is automatically set. You can set manually. You can see also in the flight management computer we select the runway we're gonna use for takeoff. So we have the Zurich International Airport over here, the Lszh in Switzerland. Also we're gonna set the runway 14 for takeoff and for landing. We're gonna have the runway length, the runway slot, the wind direction, speed, the barometric pressure, the density of the air, the temperature of the air, and also the runway conditions. If it is ice, dry or wet, it will give us the takeoff speeds, the V1, V-rotate, and V2 for full takeoff thrust like 99 or 100% of the engines right now. For this temperature, we're having also pitch attitude in rotation 9 degrees or less for takeoff, and Also takeoff speed like 140, 150 knots. We're gonna climb using the Lszh, the other instrument departure waypoints and fixes that include horizontal, vertical, indication fixes and altitude and airspeed constraint. For the initial climb of the aircraft and departure, we're gonna climb to the cruise level at 35, 36, 37, 28, 29, 30,000 feet above the sea level. We're gonna cross through some waypoints, make some turns. We're gonna initiate the descent back to the airport. Elevation like 7 or 6,000 feet above the sea level. Going to be aligned with the magnetic north pole heading of 136 degrees of the airport runway. 14 we're going to use for the Lszh localizer alignment. Also the instrument landing system that transmits the radio frequency from the threshold runway antennas, and they are received from the onboard antennas of the aircraft, then help us align with the magnetic north pole heading of 130 degrees of this specific runway heading, and also localizer heading, and also localizer radio frequency. We have to tune either manually or automatically. Also, it's going to give us the vertical glide slope. We're going to be having also, so this is the Lszh localizer. We're going to be having also the flaps extended to like 25, 30 degrees, about 60 or 70% of engine thrust for approach and landing, 160, 170 nautical miles per hour airspeed for approach and landing, and also the landing gear extended. So you see the complete flight and also the complete flight plan over here. I'm gonna start creating the flight plan now, so we have a bit more. So you can see the mouse pad here again. This view of the cockpit here. Hope you like. Also the flight management computer, the keyboard. So when I use you can see the identity over here of the aircraft is Boeing 787-900, the GNX engines, and the aircraft cycle, the index position. Here we can set our reference airport Lszh, Zurich International in Switzerland. We can use the inertial alignment using that. The index performance here. So we set zero fuel weight over here, fuel on board, gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing temperature in flight, and center of gravity in flight. So we set the route first, departure, origin, and destination over here, departure and arrival also. So we're gonna set runway 14 for that in the flight management computer. Creating this flight plan right now. So we use the departures index over here. You can set either runway 10, 14, 16, 28, 32. So we set runway 14, and we use on the left side we have the Lszh that are instrument departure waypoints and fixes. So we get departure 02 alpha. So we have arrivals here. We can use either runway 16, 28, VOM 34 ILS, 14 ILS 28. ILS 28, ILS 34, GLS 14, localizer 28, and localizer 34. So we're gonna use ILS 14, transition waypoint Amity, and the stars is other terminal arrival waypoint fixes, the Negria. So we have here in the legs, we have the route is not yet active, it's displayed with blue. So you can see the first waypoint heading and altitude and speed above takeoff, climb to the Zui, the distance one waypoint by another of the legs, climb to the cruise level over here, then descent, approach Zurich 701, and landing runway 14. So we need to set zero fuel weight 382.7 thousand pounds plus fuel on board 34.1 thousand pounds, gross weight for takeoff 356.8, cruising altitude 35,300 feet, cost index over here 100%, and the fuel freezing temperature. So we need to recirculate the fuel in flight, minus 37, cruising center of gravity over here. So you can see here, we can press the exit button. It will activate the route with white and purple magenta. So you can see first waypoint 136 heading to nautical miles from the runway, 250 knots, 1900 alpha TRO, 1 nautical mile. We make left turn, 3 nautical miles, 5 nautical miles, Zui 0526 nautical miles, 301 knots, 6000 alpha. We keep climbing to the Negria 071 heading, left turn 26 nautical miles from Zui, flight level 22,200, 301 knots, Matic 230 heading. We make a right turn after the Negria to align with Matic 12 nautical miles from Negria, 380 knots, 11,800. So we start the descent for approach and landing here. Heading 258, 6 nautical miles, Amiki 190, 10,400, Zui 276, 9 nautical miles from Amiki 180, 7,000 Alpha, Z8 701, 6 nautical miles, Zurich 701, 108, 6,000 Alpha, 290 heading, 290 heading, 10 nautical miles, 180 TRA, 5,000 Alpha, CI 14, 6 nautical miles from TRA, 180, 4,000 Alpha, Osinem. Over here 136 degrees, we make a left turn here to align with the runway and the Lszh localizer, 5 nautical miles from the previous one, 174,000, runway 14, 8 nautical miles from Osinem over here. So this is the landing part, the airspeed and the altitude. Then we have takeoff, go on. We use the flaps 15 degrees and the center of gravity automatically is gonna set 23% for takeoff on the runway, and the V-speed V1 we rotate V2 for this gross weight. Also we have some other you can see takeoff reference over here, so hope you can see more clear the takeoff reference. We have also the legs here, the route departure arrival, alternate, VNAV, progress, FMC, legs. We can set a hold in flight and also fix, and the radio frequency, Lszh, VOR localizer, Lszh, and also VOR and ADF. So we can use here virtual cockpit again. So we have a few more minutes. I'm gonna show you how to set up the engines, to start the engines. So we have to start the APU. This is gonna give us electric power and pressurizer to start the engines. The battery 120 200 volts here, alternate current, IDC generator, 130,000 kilovolts left and right engine, primary flight control computers in the auto position over here, heading reference and air data computer, flight control surfaces over here. So we have this battery here and towing power over here, FD door over here, battery, passenger oxygen over here, window heat over here, rammer turbine, and hydraulics. So you can see if we turn off the hydraulic pumps, left and right engine driving, you'll see the faults here. We need to set back to the on over here, and then to the auto. We have also the recorders, the cargo and APU fire over here, the electronic engine control over here, with the normal and alternate mode that controls the FADEX, and also the auto start system over here. We're gonna use to start the engines, EC mode. We have the fuel selection over here. We can dump some fuel to lose weight and select the nozzles on this switch and select how much fuel to remain. We have the left and right wing fuel tank, fuel booster pumps, center tanks, and the crossfeed valve. We turn the tourniquet feed either engine with other pump or either tank and balance the fuel between the right and left engine wing tanks. So we have also over here we have the wing and engine RDIs over here, as you can see on auto. We have the cabin pressurization. We have the bleeder over here from the left and the right engine that supplies air conditioning, ventilation, cabin pressurization, oxygen regulation. Also wing and engine RDIs. We need pressurizer for all this, and also for the hydraulic fluid tanks pressurization. All hydraulics need pressurizer from the engine, so from the APU. As a backup, so we have here in the auto position, the manual, we use the outflow valves, climb descent, pressurize, depressurize. In the auto we need nothing to do. We have also the lighting system, windshield wiper. This is the overhead panel system. So we're gonna make last thing before I'm gonna show you the flight plan. Now you can see displayed in the primary flight display. We're gonna set the autopilot after, so we're gonna see the systems display over here. So you can see we have the systems here, the hydraulics, the APU is running, oxygen, liquid cooling over here, So we have the electrics over here, left and right, at 130 to 200 volts, 400 hertz frequency, 120,000 kilovolts. The APU is running also the load cell and the battery, main battery, and barrage voltage to the on the APU battery. The hydraulics, where the hydraulic fluid goes, with systems use hydraulic fluid. You can see the lines, set of valves, electric, C1 and C2 primary demand, engine driven. So we have 5,100 psi's left and right and center, and the quantity of hydraulic fluid. The fuel on board the aircraft, left and right wing fuel tank, center tank. You can see the low high pressure fuel valves feed both engines over here are open. From the center or the left and the right wing we have the crossfeed over here off, but if we turn it on we can feed either engine with either pump or either tank. You see the low and high pressure fuel valves and the engine symbol. The APU is fed from the left wing. Is this motor we have 11,000 left, 11,000 in the right wing, and 11,000 in the center, total 33,700. So you can see also the minimum fuel temperature below which the fuel will freeze in fly is minus 37 degrees. So we have the recirculation of the fuel to heat it up from the engines and the fuel temperature right now automatically from the fabrics. Also the low oil and lubricant. We have the air from the engines, the packs, doors are closed, the cabin can be pressurized, the gear, you can see the pressure of the tires, the temperature of the brakes, flight controls over here. Last part, you can see the movement of the flight controls in the wing, in the tail, in the rudder, horizontal stabilizer also. So we need the movement of the flight controls to be correct. Also we have FS display over here, maintenance over here, systems again, and circuit breakers. And also the last thing, we have the checklist over here and the communications. So you can see normal menu, what to do before start, after start, before takeoff, after takeoff, approach and landing. So we use back navigation display over here. So we need to turn off the engines. I'll make the engine start demonstration right now. Turn off the engines and restart them. As you can see, so both engines are in the off position, fuel control off. So you'll see the engines are coming up with the amber warnings over here. We have fuel starvation from the engine. So you can see the Boeing 787 here. You can hear there is no engine power right now. So we start the auto start system, left and right auto start over here, both engines in the on start position. You see the amber circuit reconfiguration warnings over here. So we have pressurizer right now from the APU is admitted to the engine's starter 20% and above. You can hear there is only pressurizer right now. So we need the fuel flow available right away. So we move the fuel control valves to the on position, and we have the auto start automatically engaged. So you see above we have also fuel flow right now and high pressure pressurizer. So you're gonna see it's moving. So the auto start is off, and above 60% we have the engines running. So we can go for takeoff. Only one thing left here. You can see the autopilot engage and disengage over here. The switch, the airspeed, you can set the airspeed for a takeoff level. The LNAV and VNAV, the flight director over here, LNAV, VNAV, we have it available. So I'm gonna use only the VNAV. We have the auto throttle command also. Autopilot disengage like this. So we have also over here, gonna take us a minute, the bank angle and the heading. We're gonna set the heading to the runway over here, 136 degrees. The vertical speed over here you can set for a descent or a climb like this. you see the plus sign, so going for takeoff. We're gonna use the climb, also the altitude you can set. I'm gonna set here. So we have the autopilot set for takeoff. Flaps over here, parking brakes off, speed brakes up, retracted. So go for takeoff here. We take the air traffic control clearance and use the tiller for the nozzle steering. Advance the thrust levers will be the forward. So the runway is open for us. We take the clearance from the air traffic control, as you can see. Align with the tiller again over here. Advance to full takeoff power, as you can see. So we have full takeoff power. Align with the rudder pedal, and also press the yoke down until 80 knots. So we have 80, 90, 100 knots over here. V1, V rotate, so we pitch up 9 degrees, as you can see. So this is the positive rate of climb over here. We can leave the hands off from the flight controls after takeoff, no problem. So we have a positive rate, landing gear up over here. You can see we are 1,500 above the ground, about 3,000 above the sea. Keep climbing. We have the airspeed 180 knots, the stall speed. We are right now 2,200 above the ground, about 3,900 above the sea. The stall speed red and yellow. We climb with 4,100 feet per minute, crossing this altitude. The wind direction and speed, the pitch side is like 20 degrees right now, the bank angle. So we need also we have the ground. You can see the ground below us over here is displayed. We are like 3,000 feet above the ground. The aircraft symbol here, and the terrain below you is displayed with green, yellow and red. So if we increase over here the range, you will see a little bit more green and yellow indication. Also the flight plan, and now the engines indication. So you can see the terrain and also the vertical flight plan we need to fly. So I'm gonna start the turn now. For going to the flight plan position, following over here, you can see the runways, the lakes, also the Switzerland over here. So we make the turn, as you can see. So we take the turn now. We need to climb also to the cruise level. So this is the turn. Clear data right now over here as we turn. So we need to be aligned over here. So hope you like this view of the aircraft, also the galactic view, the star sign that we have. So this is a beautiful view over here, overflying the Switzerland. I'm gonna start the turn for back to the airport in a couple of minutes. So this is the view of the cockpit just after takeoff over here. Need to cross through these waypoints, as you can see from the flight plan. The autopilot we have set right now. The airspeed and the stall speed, you can see the red and yellow indications here. So I'm gonna be crossing through these waypoints in a couple of minutes. I need to be aligned over here. With this flight plan heading over here. So I'm gonna make a turn in 1 minute or so. So here we are overflying my homeland, Germany, the Bayern Munich in front of you, the lakes and the France on this side, also the galactic view, and beautiful Switzerland over here. So we almost reached the turn now point. We need to start turning. We turn fast, as you can see. So we can leave the hands off, no problem, from the flight controls. When we make the turn, it's automatically set the turn rate. You can use the rudder pedals also to make more steep the turn here. So we are 19,000 feet overflying here. The Bayern Munich, the Germany, the France over here. So you can see we are almost 20,000 feet. Keep turning over here. So we're gonna start the descent in a couple of minutes. Gonna increase the turn rate here. Keep climbing a bit higher. $30,000. We have to reach like 32,000. We have the chemtrails, 33 maybe. So we can see here we have to follow the waypoints one by one to approach the airport here. So we have the chemtrails in a couple of seconds. You're gonna see them, here they are. So here, this is the chemtrails, the frozen vapors from the aircraft, as you can see. Hope you like. So you have also the galactic, beautiful galactic view over here as we're flying. Here's point here, the lakes behind us, the Germany, Bayern Munich, and the France over here. So this is a beautiful galactic view with the chemtrails. So we need to start the descent now. Over here, flaps up and increase the thrust, the airspeed also, and the descent rate of the aircraft. So we're gonna start the descent now. We're going back to the airport. We have 6 more minutes left. Also use over here the speed brakes. And you can see we are overflying the runways here. So we are overflying the runway. You can see we're gonna use this runway for landing over here, so we need to follow the flight plan for descent. You can see the descent rate right now. We need to cross through some waypoints over here. So hope you like this view of the aircraft as we flying this position. We have 5 more minutes to reach the airport. Also the head-up display. So we reach this position. We need to start the turn now in a couple of minutes. You can see the waypoints we have to follow over here. Also the other screen, what indicates the engine thrust available and all. So we're gonna descend and cross through some waypoints here. Increase the rate of descent. And take the turn now over here. So we have 3 more minutes left for approach and landing, as you can see. There's a little bit left rudder over here to increase the rate of turn. Also the descent rate over here. So again, make another turn. So we need to be aligned with the runway heading over here. Almost like a few more degrees, as you can see. And we have a couple more minutes for approach and landing. So we add a little bit more thrust. Landing gear also down. And we have landing gear down. Align with the runway heading over here. As you can see, flaps also down. over here. So we're gonna be having this runway shading over here. And we have 60 more seconds to go. Before the video will end, as you can see. So we have some side wind and some wind gust. We need to be aligned with the aircraft over here with the wind component. Also add some thrust again. With the runway faster, a little bit faster. So we have also the Lszh localizer, the information that we need to approach and land the aircraft, as you can see. So we are aligned with the localizer, and we have like 30 more seconds before the video will expire. Unfortunately, maybe we're not gonna make it to the landing and touchdown part. We won't have the record time. So we have 10 more seconds over here for the touchdown. So here we are aligned, flare over here. So we flare the aircraft, as you can see. Beautiful touchdown, parking brakes and thrust reverse, idle thrust over here.